Hey guys, so I'm going to derive a formula for the distance between a point and a line segment. And why is this useful? Because I'm working on grapheme, which is a project I've been working on for years. And so if we have a line or polyline drawn somewhere in the canvas, and we want to detect whether someone has clicked on that line, suppose they clicked right here, we want to be able to find the distance between that point and the line segment here. If this distance is less than or equal to the width of the line, the thickness of the line, then, or I guess more like the radius of the line, then that is detected as clicking on the line. Right? So we'd like to implement this in a pretty fast way. I'm probably going to use asm.js for it, just to make it, speedy. And well, let's look at the problem. So we have a point here and a line segment here. And we want to find the distance from the point to the line segment. So let's call this point A, this point B, and this point, say, P. Alright, these are all vectors. Now there's three cases in terms of the closest distance between the point and the line segment. Either it's like this, where the closest point is between A and B. It might be like this, where it's closest to B. And it might be like this, where it's closest to A. Right? So the way that we're going to deal with this is we're going to parameterize this line segment as a function of t, so that f of t equals 0 equals a, and f of t equals 1 equals b. Then we compute the t value of the closest, of the altitude from P onto AB, and depending on the value of t, we'll know which of these cases it is. Specifically, if t is smaller than 0, then A is the closest. If 0 is smaller than equal to t is smaller than equal to 1, then it's in the middle. And if t is greater than 1, it's B. So how do we compute the t value of the closest approach? So first, let's define this function f. So the f, we're taking in some t, and we're going to return a vector output, and it's going to be a plus t times b minus a. Because this is linear, and when t equals 0, it's just a, and when t equals 1, it'll be b. So now we want to find the t that minimizes the norm of p minus f of t, because that's the distance from P to the point on the line, right? So this is the line that f of t is describing. And we want to find the t which minimizes this. So, if we write this out, this is going to be a quadratic in t. So, if we write this out, this is going to be a formula in t, but instead of minimizing this, we'll actually minimize this squared, because the norms, Euclidean norm squared is easier to deal with. So if we calculate this out, we'll get norm of p minus f of t, we defined it here, so a minus t of b minus a. And now let's write out the components. So a is ax, ay, and b is bx, by, and p is px, py. Then this in here is going to become the norm of the x component is going to be px minus ax minus t times bx plus t times ax, and the y component is going to be similar, py minus ay minus t times by plus t times ay. Okay, so now here's our expression. We want to minimize this. So the norm squared is just this squared plus this squared. And then we want to find the t value that minimizes that quadratic. So if we expand this out, Alright, so here's our quadratic. We can actually simplify it quite a bit, and that's a result of, there's no point really of expanding this out in the first place. But we want to maximize this quadratic, so that'll happen when t equals negative b over 2a. So that will be negative b, which is this term here, over 2 times this term here. So maximum t occurs at this expression here, which is, can be simplified as ax minus bx times px minus ax plus ay minus by times py minus ay, all over negative sign, this whole expression, 2 times the a, which is this, and this is bx minus ax squared plus by minus ay squared. Then, so this t prime is where along this parameterized line it lies. So then to find the actual distance to the line, we restrict t prime to be in the range 0 to 1. So we say t hat equals the min of the max of 0 t prime 1, like this. Now then we finally find the distance between the point and the line, which is going to be the norm of p minus f of t prime, t hat, sorry. And there we go. This is our answer.